Hi everyone. Yesterday we discussed the 9 standard integrals. The first three we discussed. So today we are going to discuss the remaining. Therefore, the first one is integral. The first one is the integral 1 upon a square plus x square into dx. Integral 1 upon a square plus x square into dx is the form 1 by a tan inverse of x by a plus c. Integral 1 upon a square plus x square into dx is the 1 by a tan inverse of x by a. After that, the second one is the 1 by a square minus x square into dx. The integral 1 by a square minus x square dx is the 1 by 2a log mod of a plus x, a minus x plus c. This is the second one. Integral 1 upon a square minus x square into dx is the 1 by 2a log mod of a plus x by a minus x plus c. Now we are going to the third one. Integral 1 by x square minus a square into dx. The integral 1 upon x square minus a square into dx is the 1 by 2a log mod of x minus a whole by x plus a plus c. This is the form 1 by 2a log mod of x minus a by x plus a plus c. Now we are going to discuss the third one. The third one is the fourth one. Now fourth one is the evaluate the integral 1 upon a square minus x square into dx is the form sine inverse of x by a plus c. Therefore, here the integral 1 upon under root a square minus x square into dx equal to sine inverse of x by a plus c. We know that in the case of under root a square minus x square or 1 by root of a square minus x square, the suitable substitution, the standard substitution is here x equal to a sin theta. The suitable substitution in this case is x equal to either a sin theta or a into cos theta. Now differentiating the derivative, therefore now we are taking the differentiation. The derivative of x is the dx, a into the derivative of sin theta is the cos theta. The derivative of sin theta is the cos theta. Derivative of theta is the d theta. The derivative of theta is d theta. This is x equal to, first of all we are taking a sin theta, then we are taking the dx equal to a cos theta into d theta. Therefore, integral 1 upon a square minus x square dx. Integral 1 upon a square minus x square into dx. Now this is, we are taking 1 by a square minus x square is the, what is the x square? A sin square theta. X square is the a square sin square theta. A square sin square theta. But the dx is the a into cos theta into d theta. Therefore dx is the a into cos theta into d theta. Now we are looking, the denominator is the common term. In this common term is the a square. Now integral 1 by under root a square is the common. Here 1 minus sin square theta. 1 minus sin square theta. Now this is a cos theta into d theta. Therefore then we can write here 1 upon square is the root cancel. Now this is a square 1 minus sin square theta. We know that this is the cos square theta. 1 minus sin square theta is the cos square theta whole root a into cos theta d theta. Therefore now we can write the integral 1 by square and root over cancel. Here also square root over cancel. That is the remaining is a cos theta. Here also the remaining a cos theta into d theta. These are cancelled. Integral 1 into d theta is the theta plus c. Integral 1 into d theta is the theta plus c. We know that integral 1 into dx is the x. Integral 1 into dx is the x. Therefore, integral 1 into d theta is the theta plus c. This is the theta plus c. Now we are looking the theta. How to find the theta? Here we are taking sin theta, x equal to a sin theta into a sending other side. We are getting sin theta equal to x by a. Sin theta equal to x by a. Therefore, theta equal to sin inverse of x by a. This is the theta. Theta is the sin inverse of x by a. Therefore, theta we can write instead of theta is sin inverse of x by a. Then you take finally the integral constant is the c. So here the integral 1 upon root of a square minus x square dx is the sin inverse of x by a plus c. First of all, we are taking x equal to a sin theta. That is the suitable substitution for x, either a sin or a cos. The derivative of x dx, sin theta derivative, the derivative of sin theta is cos theta, derivative of theta d theta. Now these are substitute in the given interval. The given integral. The integral 1 by under root a square minus x square, where x is the a sin theta. Now we are taking a sin theta whole square. This is the a square sin square theta. And the dx is the a cos theta d theta. Therefore, we are taking the common is the a square. This is the 1 minus sin square theta. 1 minus sin square theta is the cos square theta. Now these two are cancelled. Now we are getting a cos theta. This is also a cos theta. These two are cancelled. 1 into d theta is the theta. Therefore, about theta, here we are taking x equal to a sin theta. Therefore, sin theta equal to x by a. Theta equals to sin inverse of x by a. This is the fourth standard integral. The integral 1 by under root a square minus x square into dx is the form sin inverse of x by a plus c. Is it clear? Now we are going to discuss about the fifth one, that is integral 1 upon a square plus x square dx. Integral 1 upon under root a square plus x square dx is the sin h inverse of x by a plus c. This is the sin of h inverse of x by a plus c. Therefore, here a square plus x square or root of a square plus x square, either 1 by under root a square plus x square. In this case, we are taking x equal to a tan theta or x equal to a sin h theta. Therefore, its solution is put x equal to a sin h theta. X equal to a sin h theta. Is it okay? In this case, we are taking the substitution is x equal to a sin h theta. Now it's a differentiation. The derivative of x is the dx, a into derivative of the sin h theta is the cos h theta. This is the cos of h theta. The derivative of theta is the d theta. Is it okay? The derivative of x is dx, derivative of sin h theta is the cos h theta into d theta. Therefore, now we are taking the given integral is 1 upon under root a square plus x square, under root a square plus x square into dx. Now these are substitute in this 1 upon under root a square plus What is the x we are taking? The x is the a sine of h theta. X is the a sine h theta. X square means a square sine h square theta. The dx is, what is the dx is here? A cos of h theta. The dx is the a cos of h theta into d theta. Then we are writing here 1 by, you are looking the denominator, about the denominator. The term a square is the common. Therefore, now we are taking the a square, then the remaining is 1 plus sine h square theta under root. This is the a cos of h theta. A cos of h theta d theta. We know that in hyperbolic functions in trigonometry, the cos of h square x minus sine h square x equal to 1. We know that cos h square x minus sine h square x is 1. But the denominator is there 1 plus sine h square theta. Therefore, the minus of sine h square is sending to the other side. What we are getting? Cos of h square x. Cos h square x is the 1 plus sine h square x. Therefore, this is substitute in this. We can write integral 1 upon under root a square. The 1 plus sine h square theta is the cos of h square theta. 1 plus sine h square theta is the cos of h square theta. What is the remaining is here? A cos of h theta. A cos of h theta d theta. That's why we are writing here 1 upon a cos h theta integral 1 upon a cos h theta. What is the remaining here? A cos h theta. A cos of h theta into d theta. Now we are looking here, the numerator and denominator are the same. Therefore, what is the remaining is 1 into d theta. Therefore, integral 1 into d theta. We know that integral 1 into d theta is the theta. Integral of 1 into dx is the x. Therefore, integral 1 into d theta is the theta plus c. Therefore, now we are looking find the theta. Therefore, how to find theta? We are taking sin h theta equal to x by a. X equal to, we are taking a sin h theta. That's why the sin h theta equal to the value of sin of h theta equal to x by a. The sin of h theta is the x by a. Now we write, therefore theta equals to the sin h sending to the other side, it becomes sin h inverse of sin h inverse of x by a. That is, the theta is the sin h inverse of x by a. Therefore, this is the sin h inverse of x by a plus c. The sin h inverse of x by a plus c. This is the fifth one. Integral 1 upon a square plus x squared dx is the sin h inverse of x by a plus c. In this case, we are taking x equal to a sin h theta. After differentiation, we are getting the derivative of x dx. Derivative of sin h theta is the cos h theta into d theta. Now taking the integral 1 upon under root a square plus x square, where x is the a sin h theta. That means a square sin h square theta. Now the a square term is the cancel. 1 plus sin h square theta is the form cos h square theta. Therefore, square and under root cancel. We are getting a cos h theta. Therefore, numerator is also same term is there. A cos h theta cancel. We are getting 1 into d theta. Integral 1 into d theta is the theta. Therefore, we are looking to find the theta. The theta is, we know that sin h theta is the x by a. The theta is the sin h inverse of x by a plus c. Is it okay? Right? So now we are going to find the integral 1 by x square minus a square under root x square minus a square dx. Now this is the sixth one. 1 by 1 upon x square minus a square is the cos h inverse x by a plus c. The cos of h inverse x by a plus c. Therefore, here we are taking the suitable substitution is the x equal to a cos h theta. We know that this is, we can take either a secant theta x equal to a secant theta or a cosecant theta or a cos h theta. But we observing in the right hand side the cos h inverse of x by a is there. Therefore, we are taking for the solution, we are taking x equal to a cos h theta, x equal to a cos h theta. Therefore, now we are taking the differentiation. The derivative of x is the dx, the derivative of x is dx, a into derivative of cos h theta is the sin h theta, derivative of theta is the d theta. So we are thinking about the trigonometric ratios and the hyperbolic functions. The derivative of the trigonometric ratios, the derivative of the sin x is the cos x, derivative of the cos x is the minus sin x. But in the hyperbolic functions, the derivative of the sin hx is the cos hx and the derivative of the cos hx is the sin hx only, but not negative sign in the hyperbolic functions. That is the very important observation. The derivative of sin hx is a cos hx, but the derivative of the cos hx is also sin hx. Therefore, here the derivative of cos h theta, sin h theta. In the trigonometric ratios, the derivative of cos x is the minus of sin x. Is it okay? Now we are taking the integral. Now these two values are substituted in this. The given integral is the 1 by 1 upon under root x square minus a square into dx. Therefore, now this is 1 upon x square. What is the x square we are taking? A cos h theta. X is the a cos h theta. That means x square is the a square cos h square theta. X square is a square cos of h square theta minus a square under root. Therefore, now we are taking the dx is a sin h theta. What is the dx is here? A sin of h theta, a sin h theta into d theta. Now we are looking the denominator. In that a square is the common one. In that a square is the common. Therefore, 1 upon a square is the common. Here the cos h square theta minus 1 under root. A square is the common, the remaining is the cos h square theta minus 1. But here there a sin of h theta into d theta. We know that cos h square theta minus 1 is the sin h square theta. So we know that in the first year the cos h square x minus of cos h square x minus of sin h square x equal to 1. Therefore, cos h square x minus sin h square x equal to 1. Therefore, now we can write cos h square x, cos of h square x minus 1. The plus 1 is the minus 1. Now we are sending other side the sin term. That is the sin of h square of x, sin h square x. Therefore, now we are taking here the integral 1 by under root a square cos h square theta minus 1 is the sin of h square theta. Cos h square theta minus 1 is the sin h square theta. Therefore, now this is the sin h square x. Now this is the sin h square theta. Therefore, here the remaining is a sin h theta into d theta. Therefore, integral 1 upon, we are looking here under root and square terms are cancelled. Now we are getting a sin h theta. A sin h theta. Here the remaining is a sin of h theta into d theta. These two are cancelled. These two are cancelled. Now we are getting integral 1 into d theta. Integral 1 into d theta. We know that integral of 1 into dx is the x. Similarly, here the differential variable is the theta. Integral 1 into d theta is the theta plus c. Now we are looking to find the value of theta. Now we are looking to find the value of theta. We know that cos h theta. What we are taking? X equal to a cos h theta. We are taking initially x equal to a cos of h theta. Therefore, now we are taking here the cos of h theta equal to x by a. That's why we are taking theta equal to cos h inverse of x by a. First you can write cos h theta equal to x by a. Cos h is standing other side. Cos h inverse of x by a. This is the theta. Theta equals to cos of theta is the cos h inverse of x by a plus c is the required answer. Cos h inverse of x by a plus c. Integral of 1 into d theta is the theta. We can write the theta is the cos h inverse of x by a plus c is the our required solution. Is it okay? Now we are find the another one, seventh one, question number 7. This is very important proof. So all of you listen carefully here. The integral integral a square minus x square under root. Integral under root a square minus x square dx. Okay, integral under root a square minus x square dx, root over x square minus x, a square minus x square dx is the form x by 2 root of a square minus x square, x by 2 root of a square minus x square plus a square by 2 into sin inverse of x by a plus a square by 2 sin inverse of x by a plus c. So this is the form. Already I told these 9 standard integrals are very important formulas. So after the completion of these 9 can be used directly to evaluate the integrals in the corresponding formulas. Therefore, we can undoubtedly each and every one by heart these formulas. So after the completion of these formulas, we can directly apply them in the competitive or the IP level also. Therefore, here this is very important for the IP point of view, board point of view. So it goes to the 4 marks question in this one. So please listen carefully. The integral under root a square minus x square dx is the x by 2 under root a square minus x square plus a square by 2 sin inverse of x by a. So every time we are thinking the suitable substitution, but here the a square minus x square. So we first of all you can write the standard substitution. Already we know that the standard substitution, initially we are taking first of all root of a square minus x square or 1 by root of a square minus x square. The suitable substitution for x is a sin theta or a cos theta. X equal to either a sin theta or a cos theta. Therefore, in this case, we are taking put x equal to a sin theta. This is our substitution. X equal to a sin theta. Now the differentiation. The derivative of x is the dx. A into derivative of sin theta cos theta into d theta. Is it okay? The derivative of x is dx. The derivative of sin theta is cos theta. The derivative of theta is the d theta. Now we are taking the given integral. The integral under root a square minus x square into dx. Now we are taking the substitution of x is a sin theta and dx is the a cos theta d theta. Therefore, now we write under root a square minus x square is the x is a sin theta, x square is the a square sin square theta, a square sin square theta under root. What is the dx here? A cos theta into d theta. After that we are looking the under root part. In that the a square is the common one. Now we are taking the common one is a square. The remaining is 1 minus sin square theta under root. Therefore, here a into cos theta d theta. Now we know that 1 minus sin square theta is the form cos square theta. 1 minus sin square theta is the cos square theta. Therefore, now we can write a square 1 minus sin square theta is the cos square theta under root, and the remaining is a cos theta d theta. Therefore, here we are looking a square root cancel and a square root cancel. Therefore, what is the remaining here? A cos theta. Therefore, the integral a cos theta into a cos theta. A cos theta into a cos theta into d theta. We know that a into a square. We can take the a square at the beginning of the integral because it is a constant. But cos square theta is not a constant. Theta is the integral variable. Here theta is the integral variable. Therefore, cos into cos is the cos square theta d theta. Cos square theta d theta. We know that in first year, multiple submultiple angles, everybody know that cos 2a, 2 cos square a minus 1 is the form of cos 2a. Cos 2a is the 2 cos square a minus 1. Therefore, here the cos 2 theta is the 2 cos square theta minus 1. Is it okay? Cos 2 theta is the 2 cos square theta minus 1. Therefore, minus 1 is sending other side, plus 1. 1 plus cos 2 theta equal to 2 cos square theta. 2 cos square theta. Therefore, into 2 sending to the other side, we are getting cos square theta equal to 1 plus cos 2 theta by 2 is the form. Cos square theta is the 1 plus cos 2 theta by 2. Therefore, a square into the cos square theta is the form 1 plus cos 2 theta by 2 d theta. Now we are looking to find the integral of 1 plus cos 2 theta d theta. Here the denominator is the by 2. Now we can write the by 2 at the beginning. That is the a square by 2. After that, a square by 2. After that, now we find integral of 1 into d theta. Okay, integral 1 into d theta. Then also we find the integral of cos 2 theta into d theta. Is it okay? Integral cos of 2 theta into d theta. Therefore, cos 2 theta into d theta. Now we write a square. Now we write a square by 2. A square by 2. Integral 1 into d theta is the theta. Is it okay? Integral of 1 into d theta is the theta. Now we know that integral of cos x is the sin x. After that, integral of cos of ax plus b is the sin of ax plus b into 1 by a. 1 by a into sin of ax plus b. Therefore, we can write the integral of cos 2 theta is the sin 2 theta. Integral cos 2 theta is the sin 2 theta. Here the coefficient of theta is the 2. We can write 1 by 2. After we are taking finally the integral constant is the c. Integral cos 2 theta is the sin 2 theta. Before that we are taking into 2 is the theta. 2 is the coefficient of theta. That is we can write 1 by 2. After that, now we are find a square by 2. A square by 2 theta. Next write 1 by 2 into sin 2 theta. We know that 2 sin theta cos theta. Sin 2a we know that 2 sin a cos a. Therefore, sin 2 theta is the 2 sin theta cos theta plus c. This is okay. Now we have to looking the find theta, sin theta, cos theta. Therefore, now we can write a square by 2. The a square by 2. After that, theta plus sin theta. Cos theta can be written as 1 minus sin square theta under root. 1 minus sin square theta. 1 minus sin square theta is the cos square theta. 1 minus sin square theta is the cos square theta. Square under root cancel. We are getting cos theta. Therefore, now we are substitute the theta sin theta 1 minus sin square theta. Therefore, how to find? These are how to find. That means a square by 2. Everybody listen carefully. Therefore, here a square by 2. Now that is theta. How to find theta? We know that sine theta is the x by a. Sine theta is the x by a. Now find theta. The sine is sending to the other side. It will become sine inverse of. Therefore, we are getting theta equal to sine inverse of x by a. Sine theta equal to x by a. Theta equal to sine inverse of x by a. Theta is the sine inverse of x by a. Therefore, now we are taking instead of theta is sine inverse of x by a plus sine theta is the x by a. We are getting the sine theta is the x by a under root 1 minus sine square theta is there. Sine square theta means sine theta is the x by a. Sine square theta is the x square by a square plus c. Now we are looking a square by 2. The sine inverse of x by a. We are taking the LCM is a square here. A square means square root cancel. Now this is x by a into a square under root a square minus x square plus c. Is it okay here? We are taking the LCM is a square. Square and under root cancel. Therefore a into a square. Therefore now we can write here after multiplication we are getting this one. That is a square by 2 into sine inverse of x by a. Now when it is a multiple with this one, a square cancel. This is the x by 2. We are multiple with this one, a square is a square cancel. The remaining is x by 2 under root a square minus x square plus c. This is the formula of under root a square minus x square. That means x by 2 root over a square minus x square plus a square by 2 sine inverse of x by a plus c. How to evaluate? First of all, we are taking x equal to a sine theta. After that, the differentiation, the derivative of x is dx, derivative of a sine theta is a cos theta d theta. These are substitute in that root over a square minus x square. X square is the a square sine square theta. Dx is the a cos theta d theta. Now we are taking the common is a square. 1 minus sine square theta. 1 minus sine square theta is the cos square theta. Therefore, a root of a square cos square theta, a cos theta. Square and root are cancelled. We are getting a cos. That is a square cos square theta. We know that the formula of cos square theta is 1 plus cos 2 theta by 2. After that, we can write the by 2 at the beginning. The remaining is 1 into d theta, cos 2 theta into d theta. 1 d theta is the theta. Integral of sin 2 theta is cos 2 theta is the sin 2 theta into 1 by 2. We know that sin 2a is the form 2 sin a cos a. That is 2 sin theta cos theta. 2 cancel. Cos theta can be written as under root 1 minus sin square theta. 1 minus sin square theta is cos square theta. Square root over cancel, again we are getting cos theta. We know that theta is the sine inverse of x by a. Sin theta is the, what is sin theta? Sin theta is the x by a under root 1 minus sin theta is x by a whole square, that is x square by a square. Now we are taking the LCM is a square minus x square. LCM and square root cancel, we are getting 1 by a, that is x by a square. After the multiplication of this, a square by 2 sin inverse of x by a, this is a square cancel, x by 2, then we are getting under root a square minus x square plus c. This is the proof. Okay. Now we are going to the 8th standard integral, that is the integral under root a square plus x square into dx. Integral under root a square plus x square into dx. This is the x by 2 under root a square plus x square plus a square by 2 sine h inverse of x by a plus is the form. Is it okay? Under root integral under root a square plus x square into dx is the x by 2 under root a square plus x square plus a square by 2 sine h inverse of x by a plus c. Now we are taking here x equal to the suitable substitution, x equal to a sin h theta. X is the a sin h theta. We are taking x equal to a sin h. Now differentiation. The derivative of x is the dx. The derivative of x is the dx. The derivative of sin h theta is the cos of h theta. The derivative of sin h theta is the cos of h theta into d theta. The derivative of sin h theta is the cos of h theta into d theta. Now we are taking the integral under root a square plus x square into dx. Integral under root a square plus x square into dx. Therefore, we are taking here the integral under root a square plus x square is the, we are taking x equal to a sin h theta. X square is the a square sin h square theta. X square is a square sin h square theta. What we are getting the dx is a cos h theta. That is a cos h theta d theta. Therefore, now we are looking the under root part. Which term is the cancel is a square term is the common. Therefore, we are taking a square into integral a square into 1 plus sin h square theta under root. The remaining is a cos of h theta. A cos of h theta. We know that the formula of cos h square x, the cos h square x minus sin h square x equal to 1. The cos h square x minus sin h square x equal to 1. This is sending to the other side. We are getting cos of h square x, 1 plus sin h square x. This is the form. 1 plus sin h square x. 1 plus sin h square x is the cos h square x. Now we can write here the integral a square. The 1 plus sin h square theta is the cos of h square theta. Now we can write this is cos of h square theta under root a cos of h theta d theta. Therefore, now we can write square and under root cancel. Now we are getting integral a cos of h theta. Here this is a cos of h theta d theta. Now this is a into a square. Cos h theta into cos h theta, cos h square theta. A square cos h square theta d theta. This is the value of a square cos h square theta into d theta. That's why we can written as the constant. We can write the beginning of the integral a square cos h square theta. Now we know that cos h square theta is the form cos h2 theta plus 1 by 2. Therefore, the cos h square theta is the form a square integral cos of h2 theta plus 1. Is it okay? Cos of h2 theta plus 1 whole by 2 into d theta is the form. Now we can write the by 2 at the beginning. Then it will be a square by 2. Now we can written as this one a square by 2 integral cos of h2 theta plus 1 whole of d theta. Now we can write a square by 2. Already we find recently the integral of cos h2 theta, cos 2 theta is the sin 2 theta. This is the derivative of, the integral of cos 2 theta is the time sin 2 theta. Here also the integral of cos h2 theta is also sin h of 2 theta into 1 by 2. The integral of 1 into d theta is the theta, but the integral constant is the c. Is it okay? We know that the integral of sin hx, cos hx, the integral of cos hx is just sin hx. Here did not change the sign. Therefore, but integral of sin x minus cos x, integral of cos x sin x. In the hyperbolic functions, either sin hx or cos hx but we are getting the positive sign. Integral of sin hx is cos hx. Integral of cos hx is sin hx. Therefore, integral of cos h2 theta is the sin h2 theta. We are taking also 1 by 2. After that, we are going to a square by 2. 1 by 2 into sin h2 theta. Sin h2 theta is the 2 sin h theta cos theta. This is the form 2 sin h theta into cos h theta plus theta plus c. Is it okay? We can write a square by 2. 2 sin h theta cos h theta plus c. Now we can write here 2 cancel. The sine of h theta x by a. The x by a. We know that the cos h square x. We know that cos h square x minus sin h square x is the 1. But cos hx can be written as minus is sending other side plus 1. Square is also sending other side, that is under root. Therefore, this is sin h theta, root of cos h theta is the 1 plus sin h square theta plus c. Now here we are getting 1 by 2. Sin h theta is sin h theta. This implies sin h theta is the x by a. Is it okay? The sin h theta is the x by a. Now we are substituting the sin h theta is the x by a under root 1 plus sin h theta is the x by a. Sin h square theta is the x by a whole square is x square by a square. Now we are writing theta is the sin h is sending to the other side. Sin h inverse of x by a. Sin h theta is the x by a. Theta is the sin h inverse of. Theta is the sin h inverse of x by a plus c. Is it okay? We are taking here only the sin h theta is x by a. The sin h theta is x by a. Here also x square by a square. What we are getting here? The a square by 2. Taking the LCM is the a square. A square plus x square. These two are cancelled. X by a square. Square and root cancel. This is 1 by a into x by a. A into a square. Root of a square plus x square. The last one is sin h inverse of x by a. After the multiplication we getting this one. Now we are multiple with this one. We can getting here the a square cancel. A square cancel. The remaining is x by 2. A square cancel. The remaining is the x by 2 under root a square plus x square plus a square by 2 sin h inverse of x by a. Is it okay? Here a square cancel x by 2 under root a square plus x square. Is it okay? Now this is a square by 2 sin h inverse of x by a. Finally we are taking plus c. This is the formula of integral under root a square plus x square dx is the x by 2 root of a square plus x square plus a square by 2 sin h inverse of x by a plus c. In this case we have to take x equal to a sin h theta. A sin h theta. Is it okay? Now we are going to learn the last one in the standard results, standard integrals. The last one is the ninth one, that is x square under root x square minus a square into dx. Integral under root x square minus a square into dx is the form x by 2 under root x square minus a square by 2 cos h inverse of x by a. Cos h inverse of x by a plus c. Now we are looking x by 2 under root x square minus a square minus of a square by 2. X by 2 under root a square x square minus a square minus of a square by 2 cos h inverse of x by a plus c. Cos h inverse of x by a plus c. So similarly we are taking here the suitable substitution x equal to a cos h theta. X equal to a cos h theta. Now differentiating. The derivative of x is dx. The derivative of cos h is the sin h theta d theta. Once again I remind you, we did not take the opposite sign in the case of hyperbolic functions. The derivative of sin is cos hx. The derivative of sin hx, cos hx. The derivative of cos hx is sin hx. Therefore here, the derivative of cos h theta is the sin h theta, derivative of theta d theta. Now we are taking the integral x square minus a square into dx. Now we are taking the substitution. The substitution is integral x square is a square cos h square theta minus a square. Is it okay? X square is a cos h theta whole square, that is a square cos h square theta minus a square. What is the dx is a sin h theta d theta. Is it okay? The integral we are looking the under root. What is the common in that? A square. A square is the common. Therefore this is cos h square theta minus 1 under root. Here the remaining is a sin of h theta d theta. We can write here cos h square theta minus 1. Cos h square theta minus 1. We know that cos h square x minus sin h square x equal to 1. Minus sin h square is sending to the other side plus. We are getting cos h square theta minus 1 is the form sin of h square theta. Therefore integral a square sin h square theta under root. The remaining is a sin h theta d theta. Now here also square and under root cancel. The remaining is a sin of h theta, a sin h theta d theta. Now we are looking here the integral a into a is the a square. A into a is the a square. We can write the a square at the beginning of the integral. Therefore, sin h of theta into sin h of theta is the sin h square theta. We can write the sin h theta into sin h theta is the sin h square theta, sin h square theta into d theta. We know that sin h square theta is the a square into integral sin h square theta is the cos h of 2 theta. Sin h square theta is the cos h of 2 theta minus 1 whole by 2 into d theta. Is it okay? The sin of h square theta is the cos of h2 theta minus 1 by 2. Now we can write the by 2 at the beginning. A square by 2, the a square by 2 integral cos of h2 theta, cos of h2 theta minus 1 d theta. Now we are looking to find the integrals of cos h2 theta and minus 1. The integral of cos h2 theta is the sin h2 theta into 1 by 2. Integral of minus 1 into d theta is the theta. Therefore now we can write here the a square by 2. The a square by 2. We are write the a square by 2 whole of the integral of cos h2 theta is sin h of 2 theta into 1 by 2. Why we are taking the 1 by 2 before the cos h theta? That means the coefficient of theta is the 2. That's why we are taking the 1 by 2. The integral of minus 1 into d theta is the theta. Finally we are taking the integral constant is the c. We know that sin h2 theta, the sin of h2 theta is a square by 2. The 1 by 2 into the sin h of 2 theta is the form 2 sin h theta into cos h theta. Therefore, now we are writing here the 2 sin h theta cos h of 2 theta minus theta plus c. Therefore, these are cancelled. Now we know that sin of h cos of h theta is the x by a. Yes or no? Here the sin of h2 theta is the form. The sin of h2 theta is the 2 sin h theta cos h theta. 2 sin h theta cos h theta. We know that the cos of h theta we are taking x by a. But cos h square x minus sin h square x, we know that the cos of h square x minus sin h square x equal to 1. Why? How to write the sin h theta? The sin of hx is the cos h square x minus 1 under root is the sin hx. The sin hx can be written as under root cos h square x minus 1. Therefore, now we can write the a square by 2. The cos h theta under root sin h theta is the cos h square theta minus 1 minus theta plus c. Is it okay? We are taking the cos h theta. We can write the cos of h theta is the into a sending other side. It is by a. The cos of h theta is x by a. Now we are substituting that instead of cos h theta is x by a. Therefore, this is a square by 2. A square by 2 x by a. Now we are getting here x by a whole square is the x square by a square minus 1, where theta is the theta cos h is sending other side, cos h inverse of x by a. The theta is the cos h inverse of x by a plus c. Now we are taking here the a square is the common. A square is the LCM. X square minus a square. The LCM and root cancel. Therefore, we are getting 1 by a. Therefore, finally, we can write here. We can write a square by 2 equals to. We can write a square and root cancel. X by a into 1 by a is the x by a square. That is x square minus a square. We are taking the LCM is a square. Now the remaining is minus cos h inverse of x by a. The integral constant is the c. Therefore, now we can write here. A square by 2, a square by 2. Here multiple with the a square by 2, this complete term. Therefore, this complete one is multiple with a square by 2. These two are cancelled. We are getting x by 2 under root x square minus a square minus of a square by 2 minus of a square by 2 cos h inverse of x by a, cos of h inverse of x by a plus c is the final integral constant. This is our required solution. The integral of under root x square minus a square dx is the x by 2 under root x square minus a square minus of a square by 2 into cos h inverse of x by a. This is our required solution. In that case, we are the suitable substitution in this x equal to a cos h theta. After the differentiation, that is the dx equal to a sin h theta d theta. Then these are substituted in this. We are getting a cos h is a sin h square theta. Therefore, a square sin h square theta. Sin h square theta. We are remember that all of you. This is the very crucial step in this. The sin h square theta can be written as cos h2 theta minus 1. In the trigonometric formulas, sin square theta can be written as 1 minus cos 2 theta by 2. Sin square theta we can write 1 minus cos 2 theta by 2. But here sin h square theta is the cos h of 2 theta minus 1 by 2. The remaining simplification already we complete 3 or more times. That is the by 2 you can write at the beginning. This is the integral sin h2 theta. 1 d into d theta is the theta. Sin h2 theta is the 2 sin h theta cos h theta. 2 are cancelled. The sin h theta we can write under root cos h square theta minus 1. But cos h theta is the x by a. That is x square by a square minus 1. After taking the LCM, we are getting the required answer. Okay. This is today. Tomorrow onwards, let us continue the tomorrow onwards some models from these nine standard integrals. Thank you all. Right.